Welcome to this video where we discuss the new GPT-4. Every day, a new type of model is introduced that modifies the AI industry in fundamental ways, and we live in remarkable times. DALL 2, OpenAI's cutting-edge text-to-image model, debuted that year in July. Finally, we reached stability after a couple of weeks. An artificial intelligence organization released a free, public version of DALL 2 called Stable Diffusion. These two types are rather well known and have shown to be effective in terms of both quality and comprehension of the prompt. Whisper, an automatic speech recognition (ASR) model, was released recently by the AI research nonprofit OpenAI. Both in terms of stability and precision, it has been superior to any competing models. We may extrapolate that OpenAI will release GPT-4 in the future months based on the current trajectory of their releases. With the success of GPT-3, it is clear that consumers want GPT-4 to improve upon its predecessor in several key areas, including accuracy, compute optimization, bias reduction, and security. This essay will make certain assumptions and projections about GPT-4 based on AI trends and information supplied by OpenAI, notwithstanding OpenAI's silence regarding the launch or features. In addition, we'll explore the practical uses of large-scale linguistic models. The most recent developments at OpenAI and Google AI, and their implications for the field of data science, are discussed in further detail in a different piece. Just what is GPT, anyway? The Generative Pre-trained Transformer, GPT, is an online-trained deep learning model for text creation. It is implemented in AI systems for question answering, text summarization, machine translation, categorization, code creation, and conversations. Participating in the Deep Learning in Python training course will teach you all you need to know about developing your own deep learning model. You will learn about deep learning's foundations, get introduced to the TensorFlow and Keras frameworks, and construct several input and output models with Keras. GPT models may be used in a wide variety of contexts, and they can be tuned to provide optimal outcomes based on individual sets of data. Using transformers will help you save money on computer power, time, and other resources. Prior to GPT, natural language processing (NLP) models prior to GPT-1 were typically developed for discrete applications like categorization, translation, etc. Every one of them was employing some form of supervised learning. Limitations of this method of learning include its inability to generalize tasks and its reliance on highly specific data. In 2018, researchers released their findings on GPT-1, 117M parameters, to enhance language comprehension using generative pre-training. A generative language model that was trained on unlabeled input and fine-tuned on particular downstream tasks like classification and sentiment analysis has been suggested. The 2019 publication, Language Models Are Unsupervised Multitask Learners, describes the GPT-2, 1.5b parameters. To create a more robust linguistic model, it was trained on a bigger dataset with additional model parameters. To enhance model performance, GPT-2 employs task conditioning, zero-shot learning, and zero-short task transfer. In 2020, a study titled Language Models Are Few-Shot Learners, the GPT-3 parameter expansion, 175b parameters, was released. In comparison to GPT-2, this model contains a whopping 100 times as many parameters. The larger dataset was used to train the model so that it would perform well on jobs farther down the pipeline. The world was taken aback by its ability to write natural-sounding stories, queries in SQL and scripts in Python, translate across languages, and summarize texts. In-context learning, as well as one-shot and zero-shot parameters, have all been used to provide state-of-the-art results. Where does GPT-4 stand out? The debut of the GPT-4 model was verified by OpenAI CEO Sam Altman during a question-and-answer session at the AC10 online event. Here, we'll take that knowledge and use it alongside recent developments to make predictions about the model's size, optimum parameters and computation, multimodality, sparsity, and performance. Model size. According to Altman, GPT-4 won't be much bigger than GPT-3. So, we can assume that it will have around 175b, 280b parameters, similar to DeepMind's language model Gopher. The large model Megatron NLG is 3 times larger than GPT-3 with 530B parameters and did not exceed in performance. The smaller model that came after it reached higher performance levels. In simple words, a large size does not mean higher performance. Altman said that they are focusing on making smaller models perform better. The large language models required a large dataset, massive computing resources, and complex implementation. Even deploying large models becomes cost-ineffective for various companies. Parameterization optimization. For the most part, large models are not optimized to their full potential. Train the model comes at a high expense, therefore businesses must balance precision with their budget. Even though it made mistakes, GPT-3 only underwent a single round of training. However, hyperparameter optimization was out of reach for the scientific community due to prohibitive expenses. It has been demonstrated by Microsoft and OpenAI that GPT-3 might have been optimized had it been trained with appropriate hyperparameters. The results show that the performance of a 6.7B GPT-3 model may be optimized to the same level as a 13B GPT-3 model. The optimal hyperparameters for tiny models with the same architecture as big models have been found using a novel parameterization, P. With it, scientists can reduce the expense of optimizing big models. Optimal computing. The size of the model isn't the only factor affecting its performance, as DeepMind has just revealed. By training a 70B model in Chinchilla, which is 4 times smaller than Gopher and 4 times more data than big language models, they have demonstrated this. For a compute-optimal model, it is fair to expect that OpenAI will provide 5 trillion more training tokens. Hence training the model to get low loss will require 10-20x more flops than GPT-3. It has been decided that GPT-4 will be a text-only format. When answering a question, Altman stated that unlike DALL-E, the GPT-4 will not support multiple transport modes. A textual representation alone. I don't understand why. Excellent multimodal is difficult to construct in comparison to language just or visual only. It's not easy to bring together textual and visual data. It implies they have to outperform GPT-3 and DALL-E 2, which are already rather impressive. Sparsity. Sparse models cut down on computational expenses by employing conditional computation. Without excessive computational expenses, the model can readily handle more than 1 trillion parameters. With this method, we can save time and money when training huge language models. Nevertheless, sparse models will not be used in GPT-4. Why? OpenAI has previously depended on dense language models and has no plans to expand the model's current size. Alignment of artificial intelligence. Alignment improvements over GPT-3 can be expected in GPT-4. To put it simply, OpenAI's AI alignment problems are really difficult. People want us to be able to trust that language models are doing what they're supposed to be doing and respecting our culture. They're already ahead of the game because to their Instruct GPT training. It's a version of the GPT-3 model has learned through human guidance how to do tasks. Human judges favored the model more than GPT-3. Despite of typical linguistic usage. When will GPT-4 be available? There has been no official word on when GPT-4 will be released, but it seems likely that the business is putting more resources into areas like text-to-image and voice recognition for the time being. It means it may be next year, or next month. This is something about which we have no certainty. We can be assured that the issue with the previous version has been fixed and that the upcoming version will show improved results.